Hey everyone, it's Miss Taylor, and this week we only have two sections that we're talking about. So the first one is all about exponential growth and decay. So last week we started talking about the general function for exponential equations, and so the notes that will help you for the rest of this unit are these that we took last week. So these were the ones on Thursday, so I believe that would be 8.5. And we're just going to review some of that. So I've written a lot of it out already because hopefully you have it and you can either add to it, or if you want it to like go deeper into your brain, you can rewrite it again. So again, on my other side of my Cornell notes, I just wrote the general equation review. Okay, so we have this general equation y equals bm to the power of x. And I can just write this. I feel like Khan Academy uses a times the quantity b to the power of x. And so, you know, it's a little confusing with Miss Taylor because the b here is the starting point, or the initial value, or the y-intercept. So the initial value is what you will hear over and over. It also shows up as the y-intercept on the graph. So that's different than this b because that translates to this one. And then the m, and then it would be the con m. And you'll see that in textbooks too. I like this one because it corresponds nicely to y equals mx plus b. So m, you're going to hear it called the common ratio a lot, growth and multiplier. And so as we're talking about growth and decay, let's do this. So this is a little addition to our notes. So what makes an exponential function grow? So when we talk about grow, this equation is going to start somewhere. It's going to get really, really small, and then it's going in the positive direction. So to the right, because we read from left to right and we read graphs from left to right, it is going, it's increasing. And then if you follow it backwards, it gets very close to the x-axis. But again, we read from left to right, so if we're going towards the right, we are increasing. So for this one, m, the multiplier, excuse me, let's not do that. M is greater than 1, okay? So again, whatever m is, it's greater than 1. So m could equal 2, and then the equation would double. It could equal 2.1. It would be, if we did like a percentage growth, we would always see that plus, and then maybe it would grow by 5%, and that's the 5%. The other thing you'll see is fractions. So if the top number, or the numerator, is bigger than the bottom number, then this is more than 1, right? Because 4 over 4 is the same thing as 1. So if this number increases, so 6 over 4, 7 over 4, 100 over 4, this makes it increase. Okay, so conversely, decay, or actually, Khan shows it kind of like this. So we'll just do that for us. So again, we go from left to right. Going to the right, we are getting really slow, really low, really fast. And you'll see that